Hey guys, this is Stefan, and this is my presentation on the structure of the neuron. So I want to start my presentation by introducing you to my friend Chris. And as you can see, he's a beautiful body, he has a brain, and he has a spinal cord, and that's it. So with just that, let's see how Chris can react to this everyday situation. So Chris isn't reacting to his hand being on fire. So we can assume that his hand isn't telling his spine that it's on fire, and his spine isn't telling his hand to withdraw. So what's missing from this picture? Why can't Chris's hand tell his spine that it's on fire? And in general, how is information sent from one part of the body to the other? Well, the system that allows for this information to be sent is the nervous system, and the building block of the nervous system is the neuron. So information can go through a neuron through ion flow, and then the neuron can transmit that information to another neuron through neurotransmitters. And to really understand that, and to understand the function of the neuron, we really need to understand its structure. So let's build our own neuron. So the first thing we need in the neuron, of course, is its cell body and its nucleus. Its nucleus will contain the genetic info needed to make the rest of the neuron. And so attached to the cell body are dendrites. And as you can see, dendrites are sort of branchy and sticking out in all directions. And actually, the Greek word dendrite means tree. So it's up to you to think if that's a coincidence or not. And you can really see that the dendrites are branching out, and really that's to cover a lot of area so that they can really receive information from other neurons. So let's zoom in on these dendrites, because these dendrites are where that information processing begins. So let's zoom in, and here you see attached to this dendritic branch these little red things that are actually gates. And you can see the gaps in those gates on the circles are locks, essentially. And so the green squares you see are neurotransmitters, and the orange circles you see are ions. So this is how information begins in the neuron. The neurotransmitters bind to those gates, key into lock, opening the gate, and now ions can flow into the dendrite and thus into the cell. So now we have our cell body, we have our dendrites, information has entered the neuron, now it needs to travel a distance because our bodies are huge, there are distances to be covered. So what better way to do that than with a nice long tube known as the axon. And the axon does just that, it just gives a sort of tunnel for the information to go through. There is a problem with the axon, bare as you see it. It's that its membrane can be porous and ions can leak out of it, like thus. And really, it makes it difficult for information to go all the way through effectively. So what the axon does, and most axons do to compensate, is they have their own form of insulation, known as the myelin sheath. And so now let's see what happens to these ions with the myelin sheath. Look at that. They can go right through the axon. So the information has entered the dendrites, gone through the cell body, gone through the axon, and finally it reaches the axon terminal. Terminal, if you've taken a bus or a plane, terminal is the end of your road. And that, in an airport, actually, you reach the terminal to go to another airport, like information leaves this neuron to go to another neuron. And so now we're going to look at how this structure supports its function. And to do that, we really need to understand ions. And this is actually all we really need to understand when we're just talking about this. It's that ions of the same charge will repel each other, like thus. They're pushing each other off. And so inside a neuron, there's a lot of different charges of ions, but there's the charge that's going through is positive ions. So positive ions will repel other positive ions. So let's start this process from the dendrites. Positive ions enter the cell, and their presence at this sort of junction where it's not quite the myelin sheath, it's actually called the node of Ranvier. So the presence of those ions there will cause more ions to enter, which is a process that we can look at in another presentation. And so now there's just so many positive ions there that they'll repel each other. So the ions are pushed down the cell. Their presence at this gap in the insulation will cause more ions to enter. Pushing, enter, push, enter, and then push. So you can see information really traveled through the neuron. And so the presence of the ions at the axon terminal will cause the neurotransmitters to be sent off into the body and hopefully to another neuron. So you can see here how information went through the neuron. So how is it transmitted? Where did those neurotransmitters go? Well, there are many, many, many neurons in the body. It's a very complex network, so we're just going to simplify it a tad with just two neighboring neurons. So you saw the information go through the neuron, and the presence of that information at the axon terminal caused the neurotransmitter to release, and then you see it bind to the dendrites of another neuron. We actually saw this happen in our dendrite slide many, many slides ago. So now the neurotransmitter bound to the dendrite, key and lock, open up that dendrite, and then the ion went through, and then the whole process happens again. So to really appreciate how much the structure supports the function of the neuron, let's look at a case study in which structure is lost, multiple sclerosis. So this is how a neuron looks normally, and this is how a neuron looks when it's been struck by multiple sclerosis, in a disease in which the autoimmune system attacks the myelin sheaths and destroys them. So what do we think happens when the myelin sheath is destroyed? Well, we've seen this when I showed you the ions trying to get through the axon without myelin sheath. They sort of just left, and that actually means that the information can't really go all the way through the neuron. So let's see how it looks. The ion enters. This is normal. All good so far. And suddenly the ions just leak out of the neuron because there's not that insulation, and thus the information can't go all the way through the neuron, and it can't be transmitted to another neuron. So multiple sclerosis really leads to poor communication between neurons. And to really make it tangible, I'll show a case study of, I think, someone who is everybody's favorite actress, everybody's favorite TV show, Jamie Lynn Sigler, who plays mezzo-soprano on The Sopranos. She actually has multiple sclerosis, and this is a quote about her dealing with it. She says, "Suddenly, I was not able to hold my bladder, was experiencing pain and spasticity in my right leg, and was feeling very depressed. Running, wearing heels, and dancing weren't really options for me anymore." So this is the reason why I'm showing you Jamie Lynn Sigler, is to really show the real-life effects of poor neuron structure, and so that we can really appreciate how much structure supports function. And unfortunately, so far there's no cure, and multiple sclerosis can get worse over time. So that really puts my presentation, sort of makes it more applicable and easier to think about and visualize. So let's go back to Chris, though. And so now that we've built our neuron, and these neurons are fully functioning, let's see what Chris can do now that he has his own set of neurons. So Chris's hand is on fire. And so now, a signal is sent from his hand to his spinal cord. His spinal cord now knows that his hand is on fire. And so now his spinal cord has to go tell his hand to withdraw. So the spinal cord sends its own signal, and Chris withdraws his hand and is safe. So with the examples of multiple sclerosis and with Chris, hopefully I've properly demonstrated how structure supports the function of the neuron, and hopefully I've properly detailed the structure of the neuron. Thank you.